Hello guys, welcome back. This is Dr. Hadi here, and this is the second part of my previous video lecture called enzyme specificity. We have discussed three types of enzyme specificity. The first two types means the stereospecificity and the reaction specificity. These two were discussed in my previous video. If you have not gone through that video, please, I would like to request to please go and watch this video first and then come to this video. Otherwise, if you have already watched that video lecture, then you are welcome to this second part of the enzyme specificity. So the third specificity is called the substrate specificity. In order to clear the idea of substrate specificity, I would like to give you an example of the friendship. A person, you know, in our surrounding, we have different types of person, different types of friends. Some people, they don't make friendship with any other person which have more than one qualities. But there are some other person, they can make friendship with any other person. I mean, whether he is short height, tall height, some good habits, more good habits, money, does not have money, rich or poor. So this person is going to make friendship with anyone. But another person, there's another person, he's not going to make friendship with the rich people. He's not going to make friendship with highly educated, proudy people. He said, no, I would like to make friendship with only if he is poor and he is not proudy. So in this way we have two type people we have. One is making friendship with any other. This person is called relative friendship person. But other one who say that I will make friendship with only poor or only rich people, only educated or uneducated people. So this kind of person is called absolute friendship. He's going to make friendship with some certain type of people. In a similar way, in case of enzyme specificity, substrate specificity, the substrate specificity is of three types. One is called absolute specificity, the second one is called relative, and the third one is broad specificity. From the definition of substrate specificity, we can simply say that if an enzyme is acting on one substrate, suppose we have, this is our enzyme E, and here we have substrate 1, substrate 2, and substrate 3. If I say that enzyme is acting on the substrate 2, but the enzyme is not acting on substrate 1 and substrate 3, this is called what? This is called substrate specificity. Enzyme is acting on only one type of substrate, but not another. Okay, this is not enough. This example is not enough to understand the whole topic. I must teach you the three types of substrate specificity. Okay. The first one that we have, absolute specificity. In absolute specificity, enzyme act on only, look, you can see the word only here, only one substrate, only one substrate. The example that I mentioned here is quite enough for this definition. This example is quite enough, because one enzyme is acting on only one substrate. Like glucose is converting into glucose 6-phosphate. This is our substrate. The enzyme is called glucokinase. Glucokinase is only, look at that, only acting on glucose to convert into glucose 6-phosphate, but it is not acting on other cousin, friends, similar compounds of glucose, like mannose, like fructose. Glucokinase is only acting on glucose. So we say glucokinase is absolutely specific. Absolutely. This is acting on only in one substrate. I would like to give you some example in the relative specificity. Once you got the relative specificity, it will become more easy for you, because the drama is something else in relative specificity. The word only will not be there in relative specificity, but here only is there. Okay. Another example is of urea. Urea is also an organic compound, contain amino group. This urea is going to convert into carbon dioxide and NH2 group. Okay, fine. But the enzyme which is acting on the urea is urease. This urease is only acting on urea, but it cannot act on any other compound, whether similar to urea or not. So this is called urease is absolute specific. There are thousands of enzymes, among which some enzymes are absolute specific, but other enzymes are relative specific. Other enzymes are broad specific. Okay, now come to the second category of substrate specificity. In all of these three types, the discussion will be on the substrate. Fine. Now come here. In relative specificity, you will see there will be enzymes, but one enzyme will not be acting on only one substrate. In this case, one enzyme will be acting on more than one substrate, but these substrates will be related with each other. Structurally related. Now this is a very important point. Structurally related. We have one enzyme, or this is one enzyme, and in front of this enzyme we have a substrate like this, another substrate like this, another substrate like little bit egg shape, and some are like this, some are like this, some are like this. Different substrates are there. The enzyme is acting only on this one, and this one. Although these three are a little bit different, but they are similar, related. Spherical. This is a rectangular shape, this is square, this is triangle. The enzyme is not acting on these, but on these three. In this case, we do not use the word only. The enzyme is acting on only one substrate. These are different substrates, but enzyme is acting on these different substrates. For one student, this may be a great confusion. Wow, what is going on? The enzyme is acting on more than one substrate. This is not specificity. For a student, this may be a question. This is not a specificity if the enzyme is acting on more than one substrate. Yes, you are right. The enzyme is acting on this and this and this, but the enzyme is not acting on this and this. The enzyme is not acting on this and this and that. Enzyme is acting on this substrate and this. Why? Because these are related. So if this kind of situation come in front of us, we call it relative specificity. In this case, we are using the word substrate, so this is relative substrate specificity. You can add the word substrate specificity. Thus, relative specificity is further divided. The relative specificity is further divided into group specificity and bond specificity. In group specificity, we have one enzyme. Okay. It is going to act on any substrate. Look, here we have substrate 1, substrate 1, substrate 2, substrate 3, substrate 4. 4 substrate we have. This substrate contain a group. Let's suppose COOH. This contain a group NH2. This contain COOH. This contain CH3. In front of enzyme, we have 4 different substrates. 4 different substrates. But the enzyme is acting on this substrate and this substrate. These 2 substrates are different, my dear brothers, my dear students. These 2 substrates are different, but they have same group. Group is same. A substrate may contain thousands of molecules. A substrate may contain thousands of atoms, but they may contain a similar group. So these 2 are different substrates, but they contain same group. So the enzyme is acting on this substrate as well as on that substrate. Why? Because they have same group. This is called group specificity. The enzyme is specific for this group and this COH group. The example of group specificity is trypsin. I have already cleared the idea, and the enzyme of group specificity is trypsin. Trypsin is an enzyme acting on protein. Look, in front of trypsin, if I say this is my enzyme, trypsin is an enzyme, and these circles are protein. This is protein, this is protein, this is also protein and protein. Fine. These are all what? It's a protein. Protein, different protein. Trypsin will act on any protein, which contain this group, arginine, ARG. This is another protein. This is another protein, quite different. You know, in protein we have many amino acids. Like this is one amino acid, a peptide bond, another amino acid, peptide bond, another amino acid, peptide bond, another amino acid, peptide bond. The many amino acids are there. There is another a protein contain other amino acid. Different protein. Let's suppose it contains 5 amino acids. It contains 4 amino acids. So these are different. These are different proteins. Now let's suppose in this protein we have ARG. And here also we have ARG, means arginine. This is one protein, this is another protein. Different protein. Our enzyme trypsin can act on this protein, means it can break this protein, peptide bond. It can also act on this protein. And this, because why? Because both the two protein contain arginine. The condition is the presence of arginine. If arginine is there, okay, trypsin will act on this. Now, if you bring 10 different protein, listen carefully. If you bring 10 different protein, means 10 different substrates in front of the trypsin enzyme, provided if these 10 protein contain arginine or lysine, then the trypsin will act on it. So this is called relative specificity. Inside relative specificity, this is called group specificity, because arginine is a group for us now. Similarly, another enzyme, chymotrypsin. Chymotrypsin can also hydrolyze those protein which contain aromatic amino acids. So this example is enough for you to write in your exam. Now, the relative specificity could be bond specificity. In case of bond specificity, there is one enzyme acting on more than one substrate once again. But this time, the enzyme is looking for bond. Different substrate. Okay, substrate 1, 2, 3, different substrate. Enzyme is looking the bond. Do you have the bond that I like? If you have the bond that I like, I will definitely act on you. In this case, the enzyme is saying, if you have the functional group that I like, I will act on you. I will act on you as well on you, because you two both have the functional group. In this case, the enzyme will be looking for the specific bond. If the bond is there, whether you are different or not, I will act on it. If the bond is not there, whether you are similar or different, I will not act. In this case, we have glycosidase. Glycosidase act on those enzyme and those substrate which contain the glycosidic bond. Let's suppose this is glucose, this is another glucose, right? This is another glucose. Two glucose are there. Here the bond is what? The bond is glycosidic bond. If the glycosidic bond is there, it will act on it. Whether you bring another, yeah, of course, bring another one. This is another substrate. This is another substrate. Now, here is NH2. Suppose here is amino group. Here we don't have amino group. This substrate and that substrate are not 100% similar. These two are still different. Maybe in this case 2 units, there may be 3 units. There may be 3 units. 1, 2, 3 units. But in all these 3 substrates, the bond is glycosidic. Glycoside bond, glucosidic bond. Here, glucosidic bond. So because all of these substrates have glucosidic bond, so this enzyme glycosidase will act on it. This is called bond specificity. Another example is lipase. Lipase is another enzyme. It will act on those substrates which contain ester bond. Which contain which bond? Ester bond. Like in lipids. In lipids, we have fatty acid and glycerol. I have my video lecture on the lipid as well. Don't worry, you can watch. So glycerol and fatty acid combined together. In between the glycerol and fatty acid, there is a bond called what? Called ester bond. Now lipase will act on any substrate which contain this bond. Again, this is what? This is a relative specificity. This is also relative specificity because we have one enzyme acting on more than one substrate. We have one enzyme acting on more than one substrate. In both cases, one enzyme acting on more than one substrate. But the substrate are what? Structurally related. Means structurally related can be having a similar group or similar bond. If the enzyme is acting on a similar bond, it is called bond specific. If the enzyme is looking for similar group, it is called group specificity. Both the bond specificity and group specificity is called relative specificity. It's quite enough for you to write on 3 or 4 pages. Now the last one is broad specificity. In broad specificity, enzyme is acting on closely related. There is a related. Now closely related substrate. There is no word of structure over there. Closely related, maybe not structurally related, but closely related. One example is available here. That is called hexokinase. Hexokinases are a group of enzymes that can act on glucose as well as on mannose as well as on fructose. Can you call it absolute specificity? No, never. It can never be called absolute, because in case of absolute specificity, this enzyme can only and only act on only one substrate. But this is not absolute because the substrate are more than one. So it is relative. Inside relative specificity, it is what? It is broad specificity, because this time the substrates are closely related. Means we are not watching for certain groups. No, we are not looking for groups that they have same groups or they have same bond. But they are related, closely related. If you come to the structure, the structure is very similar. That's why hexokinase act on this one and that one and that one. So we call it broad specificity. This was the third specificity about enzyme. I would like to give you a summary that a enzyme specificity is of three types. The first one is called stereospecificity. The second one is called the reaction specificity. In stereospecificity, one enzyme acting on one stereoisomer but not acting on another stereoisomer in stereospecificity. In reaction specificity, one enzyme acting on a substrate, converting it into one product, but the same enzyme cannot act on the same substrate to convert it into another product. It was already recorded in my other video. In today's video lecture, we discuss substrate specificity. In substrate specificity, the enzyme is acting on the substrate in three different ways. The substrate specificity could be absolute, means one enzyme is acting on only and only one substrate. It's called absolute specificity. In relative specificity, one enzyme is acting on more than one structurally related substrate. That I have already discussed this. In relative specificity, one is a group specificity. The enzyme is looking for a particular group. In bond specificity, the enzyme is looking for a particular bond. Enzyme is not saying that I would like to act on only one type of substrate. Enzyme says, okay, fine, different substrate come in front of me, I will act on you people, provided that you must have a specific bond or you must have specific group. In broad specificity, enzyme is acting on closely related substrate like hexokinase, acting on the glucose, mannose, fructose. These are closely related compounds. See you in the next video.